Hey guys, this is Miss Youngblood here, and we're going to be going through exponent rules today. So we're going to start by looking at a video that is on Khan Academy. Let's see if I can pull it up for algebra. This is the first little video we're going to watch together.
One thing that you might appreciate in this video, I want to do a bunch of examples involving exponent properties. But before I even do that, let's have a little bit of a review of what an exponent even is. So let's say I had 2 to the third power. You might be tempted to say, oh, is that 6? And I would say, no, it is not 6. This means 2 times itself 3 times. So this is going to be equal to 2 times 2 times 2, which is equal to 2 times 2 is 4. 4 times 2 is equal to 8. If I were to ask you...
Okay, so as you can see, Khan was just showing us that when we have something raised to an exponent, that means you're writing this number this amount of times. So we're not doing 2 times 3, we're doing 2 times itself 3 times. So just like he said. I'm going to pause my recording to see if any of my students have questions about what he just went over in that video. Okay, so now we're going to look at the next part of the video to look at more examples.
To the second power is, or 3 squared. This is equal to 3 times itself 2 times. This is equal to 3 times 3, which is equal to 9. Let's do one more of these. I think you're getting the general sense if you've never seen these before.
So again, all he did was 3 2 times. 3 times 3 is 9. Did not do 3 times 2. He did 3 times itself 2 times.
Let's say I have, I don't know, 5 to the 7th power.
So I'm going to pause that and let you guys think about it while I discuss it with people who are in class. Find something else to do.
7 times. 5 times 5 times 5 times 5 times 5 times 5 times 5. That's 7, right? 1, 2, 3, 4, 5, 6, 7. This is going to be a really large number. And I'm not going to calculate it right now. If you want to do it by hand, feel free to do so or use a calculator. But this is a really large number.
Yep. So just like Khan said and my students in class today said, you write 5 7 times. Same idea. 3 2 times, 2 3 times. Or Sal, I think his name is, multiplied 5 by itself 7 times.
Well, one thing that you might appreciate very quickly is that exponents increase very rapidly. 5 to the 17th would be even a way more. I'll do this in a different color.
Okay. So
what would 3x times 3x times 3x be?
Yeah. So now he's adding a variable. So you want to look at the common thing he's multiplying and how many times he's multiplying that thing. So I'm going to pause it and let you guys think of it, and then I'll discuss it with my students who are in class. Think about how you would condense that, given what we've just seen about exponents. Okay, so now we're going to see how Sal approaches this.
Remember about multiplication is it doesn't matter what order you do the multiplication in. So this is going to be the same thing as 3 times 3 times 3 times x times x times x.
So all Sal did was regroup. He put 3's together, there are 3 3's, and all of the x's together, there are 3 x's.
And just based on what we reviewed just here, that part right there, 3 times 3 3 times, that's 3 to the third power. And this right here, x times itself 3 times, that's x to the third power.
So again, all he did was combine 3's, there are 3 of them, so it's 3 cubed. Combine the x's, there are 3 of them, so it's x cubed.
Oh.
Written as 3 to the third times x to the third, or if you know what 3 to the third is, this is 9 times 3, which is 27. This is 27 x to the third power. Now you might have said, hey, it wasn't 3x times 3x times 3x. Wasn't that 3x to the third power? Right? You're multiplying 3x times itself 3 times. And I would say, yes, it is. So this right here, you could interpret that as 3x to the third power. And just like that, we stumbled on one of our exponent properties. Note.
Okay. So as you can see, because all of these are the same 3x and they're multiplied by itself 3 times, you can also group that expression or that factor 3x and show that it's raised to the third power. So this means that you would write 3x 3 times, just like you did right here. 3x times 3x times 3x. I'll give you guys a moment to think about that.
Notice this. When I have something times something and that whole thing is to the third power, that equals each of those things to the third power times each other. So 3x to the third is the same thing as 3 to the third times x to the third times x to the third, which is 27 to the third power. Let's do a couple of more examples. What if I were to ask you, what 6 to the third times 6 to the 6th power is? And this is going to be a really huge number, but I want to write it as a power of 6. And let me write the 6 to the 6th actually in a different color. 6 to the 6th times 6 to the third times 6 to the 6th power. What is this going to be equal to? Well,
let me pause it and let's discuss this real quick. So he's writing 6 to the third times 6 to the 6th. Before he starts writing his answer, I want you guys to think about what do each of these individual parts mean. So think about that while I discuss it with the kids who are in class.
They all go together.
So hopefully while you guys
6 to the third
about it, you thought that there were 3 6's here and 6 6's here. So we want to combine them to see how many we're going to have all together. Let's see how Sal does that.
Third, we know that 6 times itself 3 times. So it's 6 times 6 times 6. And then that's going to be times, times here is in green, so I'll do it in green. Or maybe I'll make both of them in orange. That is going to be times 6 to the 6th power. Well, what's 6 to the 6th power? That's 6 times.
So again, just to emphasize, these 3 6's, he's doing a great job with colors, came from here. Now he did his multiplication, the big multiplication, and now he's going to write 6 6's.
Times itself 6 times. So it's 6 times 6 times 6 times 6 times 6. Let's see, that's 5. Then we get one more times 6. So what is this whole number going to be? Well, this whole thing, we're multiplying 6 times itself how many times? 1, 2, 3, 4, 5, 6, 7, 8, 9 times, right? 3 times here, and then another 6 times here. So we're...
Yes, we have 6 3's here, and I'm sorry, 3 6's there, and 6 6's there. So I want you guys to think about what our final answer is going to be. 6
18.
Power. Let me pause.
It'll be 18 to the 6th.
Hopefully you guys took some time to think about it. Let's finish this up.
We're multiplying 6 times itself 9 times. 3 plus 6. So this is equal to 6 to the 3 plus 6th power, or 6 to the 9th power. And just like that, we've stumbled on another exponent property.
So all we did was add the 3 and the 6.
When we take exponents, in this case 6 to the third, the number 6 is the base. We're taking the base to the exponent of 3. When you have the same base, and you're multiplying 2 exponents with the same base, you can add the exponents. So if I have, let me do several more examples of this. If I have, let's do it in magenta. Let's say I had 2 squared times 2 to the 4th times 2 to the 6th. Well, I have the same base in all of these, so I can add the exponents. This is going to be equal to 2 to the 2 plus 4.
Okay, so now he has 2 squared, 2 to the 4th, 2 to the 6th. Look at what we did with the exponents here and try to figure out how we're going to simplify that. He already kind of started it, but I want you guys to try to finish it. Think about how you finish it. So now we're going to see how Sal finishes this problem.
4 plus 6, which is equal to 2 to the 12th power. And
So all he did was add all the exponents to get 12.
hopefully that makes sense, because this is going to be 2 times 2, 2 times itself 2 times, 2 times itself 4 times, 2 times itself 6 times. So when you multiply them all out, it's going to be 2 times itself 12 times, or 2 to the 12th power. Let's do it in a little bit more abstract way, using some variables, but it's the same exact idea. What is x to the squared, or x squared, times x to the 4th? Well, we could use the property we just learned. We have the...
Okay, so I want you guys to think about that. All he did was change the base to a variable, but the idea is still the same. How would you simplify x squared times x to the 4th? So let's see how Sal finishes this problem.
Exact same base, x. So it's going to be x to the 2 plus 4 power. It's going to be x to the 6th power. And if you don't believe me, what is x squared? X squared is equal to
So
x
here he's just
equals
showing
to
how
c.
to write it out.
I figured the better. So let's do, well, let me do the other property just to mix and match it. Let's say I have a to the third to the 4th power. So I'll tell you the property here, and then I'll show you why it makes sense. When you have something to an exponent, and then you raise that to an exponent, you can...
So before he says the answer, I want you guys to think about this. If you have a cubed 4 times, what is the exponent going to be? If you have a cubed 4 times, what is the exponent? So here in the video, all Sal did was multiply 3 times 4, but that's because that this is in the parentheses. So with this one, we add the exponent because it's not in the parentheses. With this one, we're multiplying, and he's actually going to go in detail and show you why you multiply, so it should make sense.
Why does that make sense? Well, this right here is a to the third times itself 4 times. So this is equal to a to the third times a to the third times a to the third times a to the third. Well, we have...
So again, all he did was multiply this part, a to the third or a cubed, by itself 4 times. 1, 2, 3, 4. And then we can use the same property we used up here and add the exponents. So 3 plus 3 plus 3 plus 3 gets us a to the 12th. We also just did 3 times 4, which also gets us that a to the 12th. Let's see how he finishes it.
We have the same base, so we can add the exponents. So this is going to be a to the 3 times 4, right? This is equal to a to the 3 plus 3 plus 3 plus 3 power, which is the same thing as a to the 3 times 4 power, or a to the 12th power. So just to review the property.
That's why that rule works. I'm actually going to stop the video right here. If you want to continue it, you can. But this is enough for us to do the assignment that I gave from this video. So if you go to your assignment, so let's see, it's Youngblood, going to be a learner. You go to Khan Academy, you will go to Algebra Youngblood. And the first assignment I gave that's technically due tomorrow by the end of the day is multiplying powers. And that just goes over what we just did. So if you assignment, multiplying powers, I'm going to go through my 4 examples just so that you guys can. So yours should be a little bit different than mine. Let me pause my video because I think some of my students in class have questions. Okay, now we're looking at the actual Khan Academy assignment. I went ahead and signed into mine, and I can go back and show you guys after we finish this. So me and the class just went through how to simplify this. Again, like Saul said, all we're doing is adding these 2 exponents. So 4 plus 2 gets us 6. So this is going to simplify to 3 to the 6th. And then if we check it, you know we got it right. On to the next one. You guys think about how you would solve this one. So again, guys, if we look here, all we did was add the exponents. 0 plus 6 gets us 6. So our final answer for this problem is a to the 6th power. Go out. Oops. check it. We got it right. One more. Just gave us 4 for this one. So now this one is a little bit harder because we have to do another equation. It was like the first one that I had, but I skipped it on accident. So this is telling us we wanted to simplify to 6 to the 5th. So we want to have 5 6's. We have to figure out how many 6's we need here in order to get 5. So this one has 4 6's. How many 6's do we need here to get 5 6's? Go ahead and think about that. Discuss it with the kids who are in class. So you guys should have gotten 1, right? There are 4 6's here. 4 plus 1 is 5. So our answer for this one is x equals 1. Nice. So that is the assignment. And again, all I did was go to my assignment. So this is my learner home in Khan Academy. If I click my name, I click learner home, and it takes me here to Algebra Youngblood, and I just did the first assignment, multiplying powers. The next thing we're going to go over is multiplying monomials, and that's actually getting us into the algebra content. So let me pause it real quick. So now, guys, our next topic for today is multiplying monomials, and this is getting us ready to multiply polynomials, which will start tomorrow. So it's not that much more complicated than what we just did. We're just adding one more little thing. So let's look at how Saul multiplies monomials.
We wanted to multiply 5x squared and, I'm using purple, 3x to the 5th. What would this equal? Pause this video and see if you can reason through that a little bit.
Okay. Just like we did in the other problem, when we had like 3x times 3x times 3x times 3x, we can regroup these. So we can regroup this as 5 times 3 and x times x to the 5th. So let's actually take the time to look at that in a different window. Let's see if I remember. Oh, hold up. I think we're up now. Yes, good. So we're going to look in this window to see how we will actually do that. I can find my mouse.